did here is that I drew a approximate value of y is equal to ax squared plus q squared. The reason why I said y is equal to ax squared plus q squared is the approximate value is that we know that y is equal to ax squared graph right over here that I drew in the dotted line. But for the q is a constant. Constant means there's a number without any variables such as x. But we don't know exactly about the q if it's negative or positive. So also we don't know exact value of q. But I drew the approximate value of it. Y is equal to ax squared plus q squared is q is a value of a y, which mean by that is, so the dotted line is in y is equal to ax squared graph, but we moved to the y-axis direction for a q times. So that means the y direction for a q times. And so that's why I moved up to the for the q times, and this distance right over here, this distance is q. And let's talk about in terms of y is equal to ax squared plus q's graphs property. First property of y is equal to ax squared plus q's graph is that it is a transformation of y is equal to ax squared graph that I drew in a dotted line that move to the y-axis direction for q times, and this is a thing that we talked about through our graphs. And q is a number which can be negative or positive. If it is positive, it will go upward, and if it's negative, it will go down. The second property of y is equal to ax squared plus graph x squared plus q's graph is that it has its vertex as 0, q, and y plane is its axis of symmetry. The reason why it has vertex as 0, q is because ax squared plus q's graph is a transformation of y is equal to ax squared graph to the y direction, y-axis direction. And for the ax squared graph, the origin point can be either maximum or minimum, and I will just call origin as 0, 0, which the x value and the y value are both 0. And if you think about ax squared plus q squared, for the q value, that means we transform ax squared graph to the y direction, which means the y value of this coordinate will gonna be changed, but the x value will gonna be still because we didn't move it to the x direction. So if you think about it, let's think about the case when the a value is positive. When the a value is positive, as we have learned, the a value is positive, the graph goes upward, which is exactly this case right over here. And if, let's say, we move the q times, we don't know if it's negative or positive, but if you think about q value into positive, this distance between the origin point and this point will going to be aq. That means the x value is still because it is on the y-axis, which means the x value is equal to 0, and the y value will going to be q. So if you think about it, when the a is positive, which means when the a is greater than 0, the minimum point, so the minimum point will going to be 0, which x value is 0, and the y value will going to be q. Let's think about in terms of when the a value is less than 0, which means when it is negative. As we have learned, when the a value is negative, the graph goes downward. So if you transform this into downward, it will going to be like something that look like this, approximate value. But we have moved into a q times, and it can also be in the up. It depends on the value of a q. And this term right over here, the only maximum points exist as it keeps going down. And the maximum point, the x value, will going to be 0 as we have knew that it is on the y-axis. And the maximum point will going to be a cube. And the cube defines the maximum or minimum points y value. So when the a is less than 0, the maximum point will going to be 0, comma q. Let's think about in terms of y is equal to ax squared plus q squared. Example of as y is equal to 2x squared plus 4. And we could have just graphed this one, but before we think about it using our property, this means we rotated 2x squared graph to the y direction 4 times. So if you actually compare it, let's draw 2x squared graph first. So for the 2x squared graph, y is equal to 2x squared. If you input 0 to the x value, it will turn into 0. And let's think about the easy points to graph, which will going to be 1 squared. So y is equal to 2 times 1 squared, which will turn into positive 2. Now let's think about it in terms of -1. For the -1, y is equal to 2 times -1 squared is equal to 2. It also is equal to 2, so we can write that down. So we can figure out that, as we have learned, if there is no constant, the origin will going to be its minimum or maximum point depends on the a value. The reason is because even though we input the value of the negative, the positive output will going to come out, which means it won't still in the third quadrant or fourth quadrant, which shows its negative value and a negative output. So we can say that the 0, 0 is minimum point, as we have seen the a value is a positive 2. So we can actually graph that with this 3 points. So if we actually graph it, at first let's graph 0, 0 first, then 1, 2, 1, 2, -1, 2. So we can approximately see that the graph will gonna be something that look like this. And this is the approximate value of y is equal to 2x squared graph. But as we have learned, the 4 means is a positive 4, which means we are moving a positive 4 to the y direction, y-axis direction. So if you move 1, 2, 3, 4, the graph will going to be something that look like this, that satisfy this equation right over here. And these are same, but this difference between both of them is that for this graph, it moved y is equal to 2x squared graph to the forward to the y-axis positive direction. So that's the y is equal to ax squared plus q's graph means. And let's talk about the next graph.